Okay, this is my sea surface temperature analysis, and I'm going to try to speak as clear as I possibly can. In all the other videos, it's always all muggy and quiet because I'm just not talking very loud. So here it is, and these are the current sea surface temperatures. Yep, these are the current sea surface temperatures globally. I'm not sure if you can see it yet. Yep, now you can see it. And focusing on, once again, the most important regions of the ocean for the United States, called South America. Actually, you do need to include this part. Now, here are the most important regions, and as you can see, you have warming in the PNA. So the PNA is beginning to trend positive again. It has been negative for a decent amount of time, but now it's beginning to strengthen, kind of like last year when it dipped down, it weakened, and then it intensified. Now with while holding that thought, you now look at the ENSO region. Right now, it is looking like this would be potentially a Modoki La Nina. Those are very rare, but it might be a Modoki La Nina or a neutral ENSO, which is still a very high possibility, higher than having a weak La Nina. So, with that thought, you look in this region, it has intensified a bit, but I looked at the 7-day change maps, and it had the ENSO region was actually warming a bit, not a lot, but it was still warming a bit. Now focusing on my favorite part, the Atlantic Ocean. Now, as you can see, the cold is dissipating. It's still continuing to dissipate north of the UK, which the UK is right here, and it's beginning to dissipate, turning into complete warmth. And this entire Atlantic is extremely warm, except for the 100% center of the Atlantic, which is right here. Now, focusing on this region right here, I will be transferring this to 2009 and 2010 sea surface temperatures. So, these are the 2009 and 2010 sea surface temperatures of August 27th, 2009. And you will realize there are differences in this map. The first important difference to note is you have very warm waters up here. The waters aren't as warm now as they were then in 2009, but they are still well above average. But you also have very cool waters just along the coastline of Greenland, right there. Now, you have cool waters north of the UK, and you also have this interesting feature. It's kind of like, it's like an arm. It looks like an arm, it really does, coming from the southwest part of Africa. Now, focusing on this region right here, this is very similar to what we have now, except for ours is a little bit south and west of this. It's like no, not right there. It's like right here in this region, and it's very spotty. Well, it is intact, but it's dotted with cool. Like, it's dotted with colder and just chilly. There is, like, colder, maybe. Well, yeah, just colder and chilly. And this was just one solid area of cold waters. And the eastern seaboard isn't as warm as it is now in this photo right here. And that was a very good sign for a cold winter. When you have a cooler eastern seaboard, water temperature wise, that tends to promote less less warmer air being thrown inland, warming up the eastern United States. Now, what you have now is, remembering that map right there, what you have right now is, no, as a matter of fact, it's in the same exact spot. It's just spotty, very spotty, and it's weaker. It's not a very combined area. You don't have that cold here, you have warmth here, and you have very warm waters here and here, just as you did in 2009 and 2010. Now, west of Africa is very warm, and here it's cold, and it's also cold, and you will notice it is warmer than average off the east coast. It is cooling now. It's finally cooling. That's one of the main reasons why we've been having such a warm weather pattern lately, is because this area right here is just so warm that it's showing in it's throwing warm air inland, warming up the entire eastern seaboard and most of the United States. It's acting as a heat pump. Now going to the now I will go to the PDO region of 2009 and 2010, which wasn't a very big factor in that winter. So, I'm going to just go to it real quick. Now this is the Pacific Ocean, and you will see it's very different from what we have now. If you look here, you do not have that cold tongue extending from California, like Southern California and above Hawaii, just above Hawaii like this. And by the way, that's beginning to warm up again. This is warming up again, so it will begin to dissipate, but the colder is staying right here. Now, you do have warmth here. The core of the warmth is south of Alaska, and you have cool south of Alaska, and you have cool on the island chains. So the PDO region in this one is not as warm. I would say that the PDO region in this one is slightly cooler than the PDO region that we have currently, because this is red. This region right here is red, representing very warm waters, and same with this region right here. And it is cooler here, but the warmth is just overriding the cool, and the cool is beginning to weaken. Now going to the photo of 2014 and 2015, which is right here. This was a very cold and snowy winter for the East Coast, and you will see there is a very distinct similarity to what we have now. Well, not very distinct, but it is something to watch. Now, it was in neutral ENSO year, and you're seeing a very similar setup to 2009 and 2010. Speaking of the southern coast of Greenland, you have cooler waters here, very cold waters just south of Greenland, and you have very warm up here and very warm here. Now the situation in the southern Atlantic, which is, in this part of the Atlantic Ocean, you have cooler waters developing on the east coast, and this is as of August, so you already had the cool developing, but this is very similar to what we have now. It is very spotty in nature, but then it had developed into a tripole later that winter. Tripole is when you have three distinct bands of warm, cold, warm. Now, focusing on the PDO, Pacific Decadal Oscillation region, this PDO is warmer than the PDO we have currently. Because this entire region is very warm. But you do have some cold spots showing up, but it is very warm. And notice how you still had the cold north and west of Hawaii. That is a good signal for troughing in the east and a ridge in the west, causing a jet stream. Well, not a trough way down there, but a trough in the east and a ridge in the west, causing the jet stream to dip southward and then up. And having a negative NAO and a tripole that promotes Greenland blocking. So this is then, and this is now. So one more thing I will focus on is, well, this is just a entire view. So you do have very, very warm waters here, but you do have cool waters south of that very warm region. So that is a signal for troughing in the east and a ridge in the west. Now you have warm waters in the perfect regions to get Greenland blocking, and you have cool forming in the central Atlantic. Does this mean it will definitely 100% continue? No. It could change. Like, this cold could just begin to take over entire Greenland, and it would just be warm south. That signals a positive NAO and a positive AO, meaning that you will not have cold water. You will not have as many cold intrusions or as many big storms for the east. So that's just something to keep your eye on. And this cold tongue is dissipating too, and it's just right there. It's warming here and it's cooling over here. So that's just something to keep your eye on. And this was just the sea surface temperature update. And yes, if you don't like the video, just feel free to press the dislike button and comment down below on what you think I should change and what I could do better. It would really help me a lot. It would make me a better YouTuber. So thank you for watching, and have a great day.